Today we're going to be expanding upon what we already know about using long division and synthetic divisions and factors and zeros. So let's first start. How do we know that 4 is a factor of 28? And we know that 4 is a factor of 28 because there's no remainder. 4 goes into 28 7 times and there's nothing left over. And how do we know that 5 is not a factor of 28? And we know that because there would be a remainder. And in this case, there would be a remainder of 3. So what exactly does it mean for it to be a factor? So a factor actually means that when you divide, there is no remainder. So being a factor and having no remainder really go hand in hand. So here, if they tell us that x plus 2 is a factor of this polynomial, I want you to pause for just a moment and find all the factors. Now, I did synthetic division here and then took my coefficients and applied my x terms to get the quadratic x squared minus 4x plus 3, which I then was able to factor into x minus 3 times x minus 1. So they already gave me one factor was x plus 2, and then I found the other two using synthetic division and then factoring. So I want you now to work part B and find out why x minus 4 is not a factor, and then I want you to go in and sketch a graph of the polynomial and then check back here for your answer. Now here you should have ended up finding when you divided, use synthetic division to divide 4 into your polynomial, you should have got a remainder of 18, which tells us that x minus 4 is not going to be a factor. And then I just took the zeros that we already found at negative 2, 1, and 3, and found that they all cross because the multiplicity is 1 for each one of those factors, and use my end behavior and y-intercept to graph that function. So now let's just review and remember the relationship between the factors and zeros. If you look at this polynomial that they've given us here, we have the factors x plus 3, x minus 2, and x minus 4. So if I look at the factor x plus 3, my 0 is at negative 3. If I look at the factor x minus 2, my 0 is at 2. And then lastly, my 0 here is at 4. And so if I look at the zeros, I can actually give the coordinate of my x-intercept. So my x-intercept for the first one is going to be negative 3, 0. The second is going to be at 2, 0. And the last is at 4, 0. So part of the reason we're going over this is I want to introduce you to the factor theorem and the remainder theorem. The factor theorem tells us that if x minus a is a factor, so let's just say an example here would be like x plus 3. So if I will say x minus 3. If x minus 3 is a factor, then 3 would be a root or a 0. And if we plug in 3 into our function, we would get a 0. Okay? This is indicating that this is an x-intercept. You have an x-intercept. This is also a 0 of our function, and we have a factor. Now, the remainder theorem tells us that if you have your function and it's divided by something like x minus a, we'll just say x minus 5, then if we plug in that number 5, so f of 5, it's going to give us some number that is a remainder. Remember, if that remainder is not 0, that means that your factor is not, your divisor is not actually a factor. So let's take a look at this next one, and it says determine if x minus 2 is a factor of this polynomial x cubed. Now we could go in and do synthetic division, where we would do 2 into our polynomial. Our coefficients are 1, 2, negative 29, and 42. And let's see if this is a factor. I'm going to go through this, and we end up finding that we do have a 0 remainder, so x minus 2 is a factor. Now, using the factor and remainder theorem, we can actually determine if x minus 2 is a factor without doing synthetic division. And what you do is actually put in 2 into your equation for x. So you'd have 2 cubed plus 2 times 2 squared minus 29 times 2 plus 42. And if you end up simplifying this, you end up finding that when you plug 2 into your function for x, you end up getting 0, which is an indication, again, if that equals 0, then you have that x minus 2 is actually a factor of that polynomial. So what happens if you were to try to determine if x minus 1 is a factor of the polynomial x to the 90th power minus 1? Yeah, you could do synthetic division, and we could use 1 going in, but if we had x to the 90th power, we're going to have x to the 90th plus 0, x to the 89th plus 0, x to the 88, and oh my goodness gracious, we would have so many zeros here as placeholders before we could get all the way out to -1. And that's just not very feasible to do that. And so we could actually use what we just learned in our theorems to plug in 1 into our polynomial. So if we plugged in 1 into our polynomial, we would have 1 raised to the 90th power minus 1. And 1 raised to the 90th power is just 1, and 1 minus 1 equals 0. So because when we plug in that 0 into our polynomial, if we end up getting 0 for our remainder, we know that x minus 1 is a factor. So now I want you to look at these next polynomials and see if you could figure out how many zeros there are possible, and see if you can figure out a way to easily tell, and we'll circle back. So hopefully here you were able to tell that each polynomial given, that the overall degree of that polynomial is going to equal the total number of zeros. So here we've got the sentence. The total zeros of a polynomial, both the real and imaginary, are just equal to the degree of the polynomial. And this takes into consideration any zeros that are going to be rational, which is what we've dealt with so far. You also could have irrational zeros like square roots, and you also could have imaginary zeros as well. The other thing that I want to point out is that this also counts zeros that are repeated. And this is where your multiplicity comes in. Because if you had a 0 like this, or a factor like this, that was x plus 4 squared, this actually counts as a double 0 because you have a multiplicity of 2. Okay, so now I want to go through several scenarios. The first scenario is, how do I use synthetic division to find factors? And you're right, we did do this yesterday, but I want to take it a step further besides just using synthetic division. So if you want to pause it just a moment and do synthetic division with x minus 5 and then come back for the answer. So hopefully when you did synthetic division, you got a 0 remainder, which does mean that x minus 5 is a factor. But we want to find the other factors of this polynomial. So we can take our coefficients down here, and remember we're just going to decrease our original power by 1. So here we're going to have 2x cubed minus 5x squared minus 2x plus 5. And so now we have this cubic, we've got 4 terms, and anytime you've got 4 terms, hopefully you're thinking maybe we could factor this by grouping. So let's look at these first 2 terms and see what we could factor out. And it looks like the only thing we have in common is an x squared. So when you factor out an x squared, you get 2x minus 5. Well, you'll notice that's eerily similar to what we have right here. And so what I'm actually going to do is just factor out a negative. Or if you want to help yourself here, you can say you're factoring out a -1. And so you're just left with 2x minus 5. And so now we do end up having a common factor, or a GCF, between these. So we can factor out our 2x minus 5, and we're left with x squared minus 1. Now, if we're trying to find all the factors, we want to factor this as much as we possibly can. And I'm hopeful that y'all are eyeing the fact that we have the difference of 2 squares. So we can fully factor this into 2x minus 5 times x plus 1 times x minus 1. So our other factors here for this polynomial end up being 2x minus 5 x plus 1, and x minus 1. Now, I do want to point out that all of the factors of this polynomial, we would have to include that x minus 5 that they gave us. So we had x minus 5 times 2x minus 5 times x plus 1 times x minus 1. So if they ask for all the factors, we would want to include what they initially gave us. So now let's take a look if we're given two zeros or two factors. So here, there are two different ways that we could go about it. So I'm going to take this first factor, which the 0 would be 3, and I'm going to do synthetic division. So I've got, I'm going to pull my coefficients. There are no missing terms, which makes it nice. And I'm going to go through my log division. And I see that x minus 3 is a factor. Now, one thing that we could do here is once we have our coefficients, we could go in and assign our x values. So because we started out with a cubic, this is going to be a squared. And you may look and say, oh, x squared minus 3x plus 2, that can be factored. That can be factored into x minus 2 times x minus 1. And you can already see that we had already been told that x minus 1 was a factor, and we had already been told that x minus 3 was a factor, where we used that right there. And then we were able to find the other factor, x minus 2 here. So all the factors here, all the factors of that original polynomial are going to be x minus 3, x minus 2, and x minus 1. So this is one way of figuring this out. But there's also another way that you could do it. You could do synthetic division with 3 to start out with, just like we did before. And so when we do that, we end up, hold on, I'm trying to go too fast. Negative 3, negative 9, 2, 6, and there we got 0. We know right here that this is x squared, right? We know that this is 1x squared minus 3x plus 2. What we can do at this point is do synthetic division again. But this time, we don't want to go back to our original equation. We want to use our coefficients that were resulting right here, and we want to use our 0 from this second factor. So our 0 is just going to be positive 1 that we pull outside, and we're going to pull these factors right here, pull these coefficients right here. So 1, negative 3, and 2. And I'm going to go through synthetic division as I normally would, and I have a 0 remainder. Now, I want you to recognize that at this point when I did synthetic division right here, I had x squared minus 3x plus 2, right? Because I started with the cubic and I did synthetic division one time, so I have a power of 2. Now, when I have this quadratic and I do synthetic division one more time, the x variables that I'm associated with these coefficients, I'm going to decrease them by 1. So this ends up being x minus 2. So now I ended up finding my, my additional factor. So if you remember, we started out with x minus 3, which we used right there in synthetic division. Then we were told we had x minus 1, which we used in synthetic division. And using synthetic division twice, we found the final factor, which was that x minus 2. So just like in the other way that we did synthetic division and then factoring, we still get the same factors. We have x minus 3 times x minus 1 times x minus 2. And because all of these factors are multiplied together, it doesn't matter which factor comes first. Why don't you now stand up, stretch, take a 30-second break, and come back and listen to the second screencast to finish up this lesson.